Hi everyone, welcome to Module 2 videos for MA 215, which is Applied Statistics at Bellevue University, and I am Professor B. Our first video this week is going to be about comparing distributions, and in this case we're going to focus on histograms. So if we're comparing groups with histograms, looking at this particular case, I've got just one histogram, and in this histogram I have seeded clouds and unseeded clouds and their average precipitation. So the act of cloud seeding is basically an attempt to disperse substances in the air that then the ice can form around, and then that would, supposedly increase production of precipitation, which would be useful in dry areas. This histogram, not helpful at all, because I've got everything together, so I can't really tell if there's a difference between seeded and unseeded clouds. So again, we're looking at precipitation in liters, but how about instead we split these up into two different histograms. Now looking at these two histograms, I can see that there is in fact a difference between a seeded cloud and an unseeded cloud. Unseeded clouds here, as we can see, tend to be skewed right. Remember, it's always skewed in the direction of the tail. It looks like I can expect maybe a 0 to 400 precipitation, based on the numbers that I have down here. And again, these are on the same scale, which is important. But seeded clouds are also skewed to the right, as you can see. However, for my seeded clouds, I've got this outlier of about 2,800 liters. I've got this value here at 16. So really the variation is different looking at my seeded clouds. So again, if I were going to describe each distribution, unseeded clouds are skewed right. We would talk about the mode, median, etc., which is the center, somewhere between 0 and 400. The maximum volume of precipitation is near 1,200, but most clouds yield 0 to 400. On the seeded clouds, we're also skewed right with an outlier that has 2,800 liters, which we talked about. The mode appears to still be between 0 and 400, but as we can see, it's not nearly as high. The median, the middle part of our data, seems to be between 400 and 800. So we can see, just looking at these two distributions, that it seems that seeded clouds can, make a difference. And again, if we didn't make histograms, we could also look at just our raw data, or our descriptive statistics or summary statistics, which we learned how to do in our last lessons. If I look first at the IQR and the standard deviation, which would be standard deviation here, and interquartile range would be right here. These are measures of spread. So again, we're looking at how spread out our data is. So the fact that if I look at the IQR of seeded much greater than the IQR of unseeded, the standard deviation of seeded much greater than the standard deviation of unseeded, what that tells me is that the seeded clouds have much more variation. So there's a lot more spread in my graph, which makes sense because looking at the histogram, we knew that 2,800 was out there, whereas on the seeded clouds, or unseeded, it didn't go nearly as far. Looking at the mean and the median, what those would tell me, again, is that the seeded clouds have much greater mean and a much greater median than the unseeded clouds, which of course means on average, whether I'm looking at mean or median, on average I'm expecting more precipitation from a seeded cloud than an unseeded cloud. We can also notice that our distributions are skewed right. And how do we know that it's skewed right? Because if I'm looking at the mean, it's much higher than the median, which means I've got some tail outliers happening on the right side that are drawing the mean towards it. What I would like for you to do is look at these two distributions and see if you can come up with some observations about shape, center, and spread for women's heights. Notice the histogram on the left shows women's heights in the US and on the right in Europe. So press pause, try that, and then press play to check your work. So the very first thing that I notice about these two is that we're not dealing with the same scale. So right away, I don't love this. This scale has a frequency of up to 16, which means their highest bar is at 15, whereas over here, my highest bar is at 20. So if I want to compare apples to apples, it's really important to understand that these are not the same scale. Same thing down here. These are pretty close to the same scale. I think 180 would probably be out here, but it got cut off. So just so you know, you're not dealing with the same scale. What I do notice is that they're both unimodal and they're both symmetric, but it seems to me that the heights for US women over here tend to be a little bit more spread out. So this one has a very clear high bar, and then we've got obviously the rest of our sort of normal bell curve, whereas this one doesn't go nearly as far down. So I would say that this one has much more variation than the European women.